So following on from the previous video, we got to this stage here where we were trying to integrate this. And in order for us to integrate this, our eyes should zoom into this complicated square root bit here. And then we needed to create a triangle in such a way that this complicated square root bit is true. So we would then create a triangle. And then from our triangle, tan theta would be this. So from our triangle, we would obtain this, and we would obtain this. So we can put everything back into here, substitute everything back into here. It would then give us this. Tidy this up. It would then give us this. So we were trying to integrate this, but rather than trying to integrate this, we would try and integrate this. It's a lot simpler. So now it's just a matter of integrating this. So integrating this would give us this. So we've done this in the last video. Integrating that, it would then take us to this stage here. So integrating that, it would then take us to this stage here. And this is a stage that we got to in the last video. Okay, so now we're going to continue from here. So this is our answer here. So this is our answer here. But the thing is, we don't want the answer in terms of theta. We want it in terms of x, because we were trying to so this is a screen from the previous video. We were trying to integrate this, create our triangle in such a way, and then from the triangle we would obtain this and this. Okay, so this is what we've seen in the previous video. So now if you look at our answer was this. But the thing is, we don't want the answer in terms of theta. We are trying to integrate this here. We are trying to integrate this, and everything is in terms of x. We don't want the answer in terms of theta, so we need to translate this theta thing back into x. Now, at the moment it's sine theta, but let's say suppose the answer is 1 over 4. Let's say tan theta. Let's just imagine the answer is this. If this is your answer here, then you can just go back and look at this bit here. Tan theta equals this. So you would then put x over 2 back into the tan theta. Let's say if you had, let's say, instead of sine theta, let's say the answer is, let's say, secant of theta. Then let's just imagine the answer is this. Then you would go back to your initial screen, and then look at this bit here. Secant theta equals this thing here. Then you would put this block back into your answer here. But the thing is, our answer is, we've got a sign here. So there's nothing convenient. You see, if you had a tan or a secant, then you can immediately put it back into there. But our answer here is in terms of sine theta. So visualize this thing here. Well, we need to translate this back in terms of x, but at the moment it's in sine theta. So visualize this thing here as this, minus. So hang on. So visualize this whole thing here as, well, basically break this up into two fractions. But visualize this thing here as this. Okay, and then 1 over sine theta is really the cosecant. And then from the diagram, so our answer here now is this. You've got this block multiplying with this block here. Okay, so rather than having our answer as this, we're going to visualize this as this. Okay, so now if you look at cosecant, well, cosecant, look at the diagram. Cosecant, well, sine would be this. Cosecant would be this thing divided by this thing. So cosecant is this thing divided by this thing. So going back down here, cosecant would be the hypotenuse divided by the opposite. So this block here is exactly the same as this block here. So this is this block here. So this is this bit here. So now everything now is in terms of x. So this here is your final answer. Okay.